Okay, my name is Praveen Kumar, Assistant Professor Physics Pandit NRS Government College Rohtak. Today we will take the topic of compound pendulum. This topic is related with the motion of simple harmonic motion in which a body moves to and fro, and under the action of restoring force it comes towards the main position, and force acting is directly proportional to the displacement from the mean position. So there are many bodies which do simple harmonic motion, just like simple pendulum. There is also a compound pendulum. So what is the definition of compound pendulum? It is also called a physical pendulum or a rigid pendulum. The compound pendulum is just a rigid body, any rigid body of whatever shape, any shape. There is no restriction of shape, any shape, whatever shape, capable of oscillating about a horizontal axis through it. Last line gives the main condition: capable of oscillating about a horizontal axis passing through it. The point in which the vertical plane passing through center of gravity of the pendulum meets the axis of rotation is called its point or center of suspension. Again note, suppose this is center of suspension. This is the point in which a vertical plane passing through center of the pendulum, suppose this is the center of gravity, a center of pendulum G. This is the axis which is passing through both these points, center of gravity of the pendulum, and this is also the axis of rotations. This point is called center of suspension, and the distance between this point S and the point G is called the length of the pendulum. The length of the pendulum here is Sg, and let's suppose it is L. So this diagram shows a vertical section of the rigid body or a compound pendulum free to rotate about a horizontal axis passing through the point or center of suspension S. In its normal position of rest, its center of gravity G naturally lies vertically below the distance, below the S. This point G in its rest position lies vertically below the point S. And distance between SG is called L. Now we have to give oscillation in this compound pendulum. Let the pendulum be given a small angular displacement theta into the dotted position. Let we give some displacement, it's like this. Okay, इसको हम थोड़ा सा डिस्प्लेसमेंट देते हैं ये डॉटेड पोजीशन में, तो इसकी नई पोजीशन सपोज दिस विल बिकम्स लाइक दिस. ये पेंडुलम डॉटेड होके ऑसिलेशन होके थोड़ा सा यहाँ आ गया, तो दिस जी पॉइंट कम्स आउट टू बी नाउ डॉटेड पोजीशन कम्स एट जी डैश, and this will becomes new axis of rotation. Let theta is the displacement, angular displacement. तो स्मॉल एंगुलर डिस्प्लेसमेंट थीटा हमने दिया, नई पोजीशन में आ गया पेंडुलम, सेंटर ऑफ ग्रेविटी शिफ्ट होके जी से कहाँ आ गया, जी डैश पे आ गया. ठीक है, एस जी डैश बी लेंथ तो वही रहेगी, एस जी डैश बी क्या रहेगी, एल ही रहेगी. weight of the pendulum acting vertically downward at G. उसी तरीके से अगर हम कहें ये weight vertically acting downward, again two component, this is mg cos theta, and जो restoring force का जो component है again this is mg sine theta. Here if we take angular motion, then it will form a couple. This is mg sine theta, force acting, and this is perpendicular distance of this force is L sine theta. So torque, moment of restoring couple, if we talk about moment of restoring couple, it comes out to be mg L sine theta. This one, this is the moment of restoring couple, minus mgl sine theta. Negative sign indicates that couple is oppositely directed to the displacement. Let I, capital I, is the moment of inertia. Let I be the moment of inertia of the pendulum about the axis of suspension through S, and d square theta by dt square, what it will become? Alpha. It is called angular acceleration. Okay, angular acceleration. So we know that torque is equal to I alpha, and torque I, and alpha is, what is alpha? Alpha is d square theta by dt square is equal to minus mgl sine theta. This will be the equation of motion of compound pendulum. But if we assume theta is very small, then sine theta nearly becomes equal to theta. So this comes out to be I square d theta by dt square is minus mgl theta. Okay, and acceleration becomes d square theta. This becomes minus mgl theta by I. Yeah, we can write it as minus mu theta, where mu is equal to mgl by I. ओके, वेयर म्यू क्या बनेगा? अगर म्यू को हम कहें, म्यू होगा एक्सीलरेशन बाय डिस्प्लेसमेंट. सो म्यू इज कॉल्ड एक्सीलरेशन पर यूनिट डिस्प्लेसमेंट. ओके, पर यूनिट डिस्प्लेसमेंट. सो पेंडुलम क्या करेगा? एग्जीक्यूट. पॉइंट इज दैट सिंपल हार्मोनिक मोशन की कंडीशंस क्या होती है कि एक्सीलरेशन शुड बी डायरेक्टली प्रोपोर्शनल टू एंगुलर डिस्प्लेसमेंट. ओके, म्यू इज कांस्टेंट, mgli कांस्टेंट, तो d square theta is directly proportional to theta. This is acceleration. Acceleration is directly proportional to angular displacement. So motion is simple harmonic motion. Pendulum executes simple harmonic motion, and its time period. Now time period of simple harmonic motion, okay, is given by 2 pi L over G. We know that. Okay, 2 pi L over G, or in terms of mu it is given by 2 pi 1 by mu. If we put mu, value of mu from this here, it comes out to be mgl and by I, and I come upward. So this will be the first formula of time period of compound pendulum. Okay. If we consider I naught as the moment of inertia of the pendulum, suppose I naught is the moment of inertia of the pendulum about an axis through its center of gravity. Suppose what I am saying, let I naught be the moment of inertia. Moment of inertia of the pendulum about an axis through its center of gravity, that is G, पैरेलल टू द एक्सिस थ्रू एस. जैसे ये हमारा ऐसे था, मान लिया ऐसे था, ये एस, दिस इज जी, दिस इज एस एक्सिस, सपोज दिस इज जी एक्सिस, हॉरिजॉन्टल एक्सिस हम लें. तो इसके क्रॉस अगर आई नोट मोमेंट ऑफ इनर्शिया है, इसके क्रॉस अगर आई नोट है और आई इसके क्रॉस है और ये लेंथ है एल, तो वी हैव फ्रॉम थ्योरम ऑफ पैरेलल एक्सिस आई will becomes equal to moment of inertia of a parallel axis passing through center of gravity plus mass और इनके बीच की दूरी, that is ml square. okay, तो I is equal to I naught ml square. and if k be its radius of gyration of the pendulum about its axis through G, किसकी बताना पड़ेगा ना, about this axis through G. G के क्रॉस जो एक्सिस है, इसके क्रॉस ये रहा, इसके अक्रॉस यदि पेंडुलम की रेडियस ऑफ जायरेशन जी है, तो इन टर्म्स ऑफ रेडियस ऑफ जायरेशन वी नो दैट मोमेंट ऑफ इनर्शिया बिकम्स सिंपली एम के स्क्वायर. सो जो आई हमारा फार्मूले में आया है टाइम पीरियड के, वो क्या हो जाएगा, एम के स्क्वायर प्लस एम एल स्क्वायर. सो इफ वी पुट द वैल्यू ऑफ मोमेंट ऑफ इनर्शिया I by mgl, इसमें if we put the value of I, m we can take common, k square plus l square by mgl, और we see m से m आपका कट जाएगा, तो टाइम पीरियड will becomes 2 pi k square by L square GL, or you can write it in any different way. You can write it also like this. L से अगर हम 1 by G बाहर निकाल लें, तो it will becomes K square by L plus L. okay, you can also write it like this. So if we compare it, this is the formula of time period of compound pendulum. If we compare it with 2 pi L over G, we see that instead of L, here comes out to be distance k square by L plus L. ये आ जाए, तो इट मीन्स लेंथ यहाँ पे इंक्रीज हो जाएगी. टाइम पीरियड ऑफ द पेंडुलम इज द सेम एज दैट ऑफ ए सिंपल पेंडुलम ऑफ लेंथ. टाइम पीरियड वही रहेगा, बट लेंथ ये हो जाएगी हमारी न्यू लेंथ. तो टाइम पीरियड ऑफ compound pendulum is same as that of simple pendulum of length L, where L is equal to k square by L plus L. This length L is therefore called the length of an equivalent simple pendulum, or it is also called reduced length of the compound pendulum. Since k square is always greater than 0, the length of the equivalent simple pendulum, or we can say reduced length, is always greater than the length L, the length of the compound pendulum. ठीक है, तो this is compound pendulum. Again, if you want to understand, we can say, if I will repeat it, this is compound pendulum is any rigid body oscillating about a horizontal axis passing through it. Suppose इस axis के along ये horizontal rotate कर रही है, ठीक है. Suppose S is point of suspension, G is center of gravity, then distance between S and G is called length L. We give some displacement, small displacement theta. So there is restoring couple forces are this, and for this mg sin theta multiplied with L sin theta, mg sin theta multiplied with L, this L gives torque about this, so this will becomes mgl sin theta restoring couple, and torque is I alpha, you know, and I is called I alpha is this torque, restoring torque. Because theta is very small, then we can say that sin theta is theta I square, this will becomes this, acceleration will becomes mgl theta by I, or या mu I, where mu is called acceleration by theta. ये क्या है, acceleration by theta is called angle acceleration per unit displacement. We know that time period is given by 2 pi mgl theta, or we can also say in terms of mu, it becomes because mu will become, if you put here value of mu r, then I, then it is ml square. Again why you can ask how time period will becomes 2 pi 1 by mu. Let solve this. Here I put 2 pi L over G is 1 by mu. We know that mu is equal to mgl by I, and I generally ml square, so L से N cancel, it will becomes G by L. Okay, understand, mu becomes G by L, तो mu को रखोगे यहाँ पे G by L. Okay, so it will becomes I by mu, or mu is this one. Then we have to find I के लिए हम मान लेंगे कि अक्रॉस G हमारा I नोट है, तो इसके अक्रॉस है ना सस्पेंशन के अक्रॉस, तो पैरेलल्स थ्योरम लगा के we comes out to be this one, and parallels theorem says mk square plus ml square, and put this value and solve this. So we see that instead of L you get this length, and this is called reduced length, and this is the time period of the compound pendulum is same as that of simple pendulum, but L is replaced by capital L, which is called the length of an equivalent simple pendulum, or the reduced length. This is today lecture. It is compound pendulum. This topic is covered in honors first sem mechanics physics. Okay, thank you.